Hi there. Today, we are going to talk about two types of numbers, rational and irrational. Understanding the difference is super important in math. So, let's break it down. A rational number is any number that can be written as a fraction, meaning it can be written as a ratio of two whole numbers like 1 divided by 2, 3 divided by 4, etc. An irrational number is a number that cannot be written as a fraction. Its decimal form goes on forever without repeating. For example, numbers like pi and the square root of 2 under root 2 are irrational. Let's go through each question and figure out if it's rational or irrational. First, let's look at the number 2.353535. Do you notice how the numbers 35 keep repeating forever? That's called a repeating decimal. Since we can write repeating decimals as fractions, this is a rational number. Next, we have 0.6 with a bar over it, meaning the 6 repeats forever, like this, 0.66666 and so on. This is also a repeating decimal, so it can be written as a fraction. That means it's a rational number. Now, let's look at 2.236067 and so on. Notice how the decimal goes on forever, but it doesn't repeat in any pattern. When the decimal doesn't repeat and keeps going, that's a sign it's an irrational number. Next, we have square root 7, or the square root of 7. This is the number that you multiply by itself to get 7. If you try to find the exact decimal, it will go on forever and never repeat. So, square root 7 is an irrational number. Now, e is a very special number that comes up in math, especially when dealing with things like growth and decay. Its decimal goes on forever without repeating. So, e is an irrational number. Next up is pi. We use pi when we calculate the circumference of a circle. Pi is another example of a number that goes on forever and doesn't repeat, so it's an irrational number. Here we have 5 plus under root square root 11. The square root of 11 is an irrational number, and adding it to 5, a rational number, doesn't make it a nice fraction, since it contains an irrational part, 5. Square root 11 is an irrational number. Here, we have square root 3 square root 13. Both square roots are irrational numbers, and adding them together still gives us an irrational result. So, square root 3 square root 13 is an irrational number. Here we have 15 quarters. This is a fraction, and we can divide 15 by 4 to get a nice decimal 3.75. Since this is a fraction, it's a rational number. Finally, we have 2 minus square root 2, 2 square root 2. If you multiply these two binomials together, you can simplify it. It actually works out to a whole number. 4 to 2 equals 2, which is a rational number. So, this one is a rational number. To represent these numbers on a number line, you need to first have an idea of their approximate decimal values, and then place them at the corresponding positions on the number line. Here's how to do that for each of the given numbers. Square root 2 approximately equals 1.414. It will be a bit more than 1, but less than 2 on the number line. Square root 3 approximately equals 1.732. It will be a bit more than 1.5, but less than 2 on the number line. 4 and a third equals 4 and a third equals 4.333. It will be a little more than 4, but less than 5 on the number line. Minus 2 and a seventh equals minus 2 minus 1/7 approximately equals minus 2.143. It will be a little more negative than minus 2, but less negative than minus 3 on the number line. 5 divided by 8 equals 0.625. It will be a little more than 0, but less than 1 on the number line. 2 3/4 equals 2 3/4 equals 2.75. It will be a little more than 2.5, but less than 3 on the number line. Question 3. Express the following as a rational number p, q, where p and q are integers and q does not equal 0. 0.4 bars. 0.37 bars. 0.21 bars. First, let's take 0.4 bars. This means that the digit 4 keeps repeating forever. 0.4444 and so on. To turn this into a fraction, let's call this number x. So, x equals 0.4 bars. Now, to get rid of the repeating decimal, multiply both sides by 10. This shifts the decimal point to the right. So, 10x equals 4.4444 and so on. Now subtract the first equation from the second. So, 10x, x equals 4.4444 and so on minus 0.4444 and so on. This simplifies to 9x equals 4, and when we solve for x, we get x equals 4/7. So, 0.4 bars is the same as the fraction 4/7. Next, let's look at 0.37 bars. This means that 37 keeps repeating forever. 0.373737 and so on. Let's call this number y. So, y equals 0.37. Now, multiply both sides by 100 to move the decimal point 2 places to the right. So, 100y equals 37.373737 and so on. Next, subtract the first equation from the second. 100y minus y equals 37.373737 and so on minus 0.373737 and so on. This simplifies to 99y equals 37, and solving for y gives y equals 37/99. So, 0.37 bars is the same as 37/99. Finally, let's take a look at 0.21 bars, which means that 21 repeats forever, 0.212121 and so on. Let's call this number z. So, z equals 0.21. Just like before, we multiply both sides by 100 to shift the decimal 2 places to the right. So, 100z equals 21.212121 and so on. Now subtract the first equation from the second. 100z minus z equals 21.212121 and so on minus 0.212121 and so on. This simplifies to 99z equals 21, and solving for z gives z equals 21/99. So, 0.21 bars is the same as 21/99. Question 4. Name the property used in the following. First, let's look at this equation. AB, B equals A, 4B. This is called the associative property of addition. It means that the way we group numbers when we add them doesn't matter. Whether you add AB first or B4 first, you'll still get the same answer. Next up, we have square root 2 square root 3 equals square root 3 square root 2. This is the commutative property of addition. It says that the order in which you add numbers doesn't change the result. So, square root 2 square root 3 is the same as square root 3 square root 2. You can switch them around, and the answer will be the same. Now, here's something simple. X minus x equals 0. This is called the subtraction property of 0. It means that when you subtract a number from itself, you always get 0. So, x minus x equals 0. No matter what number x is. Here's a fun one. A, B plus C equals A, B plus A, C. This is the distributive property. It tells us that if we have a number outside the parentheses, we can multiply it by each number inside the parentheses. So, A times BC is the same as A times B plus A times C. Take a look at this. 16 plus 0 equals 16. This is the identity property of addition. It says that if you add 0 to any number, the number stays the same. So, 16 plus 0 is just 16. How about this? 100 times 1 equals 100. This is the identity property of multiplication. It means that multiplying any number by 1 doesn't change the number. So, 100 times 1 is still 100. Here's another cool one. 4 times 5 times 8 equals 4 times 5 times 8. This is the associative property of multiplication. It says that the way we group numbers when we multiply doesn't change the result. So whether you multiply 5 times 8 first or 4 times 5 first, you'll get the same answer. And finally, let's look at this. A, B equals BA. This is the commutative property of multiplication. It says that when you multiply numbers, you can change their order, and the result will be the same. Now, we are going to talk about different properties of inequalities. These are rules that help us understand how numbers behave when we compare them. Question 5. Name the property used in the following. Let's go through each one step by step. This is an example of the transitive property. Imagine you're comparing three things, -3, -1, and 2. If -3 is smaller than -1, and -1 is smaller than 2, then we can say that -3 is smaller than 2. 2. It's like following a path from one thing to the next, and you can jump to the final conclusion. Next, we have the reciprocal property. This rule tells us that if one number is smaller than another, its reciprocal, that's 1 divided by the number, will be bigger. So, if a number is small, its reciprocal is large. It's like flipping the number upside down. This is the addition property. If A is smaller than B, and we add the same number to both sides, the order doesn't change. Here we have the multiplication property with a positive number. If you multiply both sides of an inequality by a positive number, the direction stays the same. Now, this is a twist. The multiplication property changes when you multiply by a negative number. If you multiply both sides of an inequality by a negative number, the inequality flips. Finally, we have the trichotomy property. This rule says that for any two numbers, there are three possibilities. Either one number is bigger, they're equal, or one number is smaller. It's like having three choices for how two numbers can relate to each other. Question 6. Find two rational numbers between. Let's begin by finding the average of two fractions, 1 by 3 and 1 by 4. 1 divided by 3 plus 1 divided by 4 equals 4 plus 3 divided by 12. We first find a common denominator. The least common denominator of 3 and 4 is 12. So, we rewrite the fractions. 1 divided by 3 becomes 4 divided by 12, and 1 divided by 4 becomes 3 divided by 12. Now, we add the fractions. 4 divided by 12 plus 3 divided by 12 equals 7 divided by 12. On the right side, 4 plus 3 divided by 12 also equals 7 divided by 12. Next, to find the average, we divide the sum by 2. 7 by 12 divided by 2. Dividing by 2 is the same as multiplying by 1 divided by 2. 7 divided by 12 times 1 divided by 2 equals 7. Divided by 24. So, the first rational number we get is 7 divided by 24. Now, let's move on to the next part. We need to find the average of 7 divided by 24 and 1 divided by 3. To add 7 divided by 24 and 1 divided by 3, LCM of 24 and 3 is 24, becomes 15 divided by 24. To find the average, divide the sum by 2, 15 divided by 24 divided by 2. Again, dividing by 2 is the same as multiplying by 1 divided by 2, 15 divided by 24 times 1 divided by 2 equals 15 divided by 48. Simplify 15 divided by 48 by dividing both the numerator and denominator by 3. 15 divided by 48 equals 5. Divided by 16. So, the second rational number we get is 5 divided by 16. Let's start by finding the average of 3 and 4. To find the average, first add the numbers together. 3 4 equals 7. Next, divide the sum by 2. 7 divided by 2 equals 3.5. So, the first number we get is 3.5. Now, let's find the average of 3.5 and 3. To find the average, add the numbers together. 3.53 equals 6.5. Now, divide the sum by 2. 6.5 divided by 2 equals 3.25. So, the second rational number we get is 3.25. Let's start by finding the average of 3 divided by 5 and 4 divided by 5. To add the fractions, keep the denominator the same. 3/5 plus 4 divided by 5 equals 3 plus 4, divided by 5 equals 7 divided by 5. Next, divide the sum by 2. 7 divided by 5 divided by 2. Dividing by 2 is the same as multiplying by 1 divided by 2. 7 divided by 5 times 1 divided by 2 equals 7. Divided by 10. So, the first rational number we get is 7 divided by 10. Now, let's find the average of 7 divided by 10 and 3 divided by 5. To add these fractions, we need a common denominator. 3 divided by 5 becomes 6 divided by 10. So, now we add 7 divided by 10 plus 6 divided by 10 equals 7 plus 6 divided by 10 equals 13 divided by 10. Next, divide the sum by 2. 13 divided by 10 divided by 2. Again, dividing by 2 is the same as multiplying by 1 divided by 2. 13 divided by 10 times 1 divided by 2 equals 13 divided by 20. So, the second rational number we get is 13 divided by 20.